Hello again, and welcome back to yet another edition of Algebra 2 Notes with Miss Faust. Today's notes revolve around quadratic equations and the quadratic formula, which again I hope is review from sometime in your mathematical past, but in case it's not, we'll go through a couple examples together, and then you should be good to go. So the big idea is, as always, we have a quadratic equation that looks something like this. Doesn't always equal 0 right from the beginning, but that's part of what we have to do in order to solve using the quadratic formula. So if we want to use the quadratic formula, which we're actually going to want to use pretty often, the first thing that you want to always do is make sure you get an equals 0 on one side. So you do that just by moving everything using addition and subtraction and then combining like terms. So if you have your equation in this form, then the quadratic formula states that x is equal to the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So quadratic formula involves finding this a, b, and c, plugging them in, and then chugging through the arithmetic to get your two answers. This plus or minus is where the two answers come from. One answer is from adding, one answer is from subtracting, and then that division by 2a is always the last thing you do. So one piece of the quadratic formula is this inside part, and I know you can't see the yellow very well, that's intentional. Just sort of supposed to be highlighting it for you. So that inside part gives us some really valuable information when we're solving quadratics. So sometimes we just want to look at what that number is equal to. So that value, b squared minus 4ac, is called the discriminant. And the discriminant is helpful because it determines the types of solutions to a quadratic equation. Particularly, it tells us if our solutions are going to be real or imaginary. So often a triangle, for some reason, is used to denote the discriminant. So when you see that triangle or that delta symbol, that equals b squared minus 4ac. If that whole thing, so if the triangle is greater than 0, or positive is another way to say that, then what that tells us is that the equation has two real solutions. If the discriminant, or the triangle, is exactly equal to 0, we have exactly one real solution. And the reason for that is if you imagine replacing this with a 0, when you take the square root of 0, you get 0. So you just get negative b plus or minus 0, both are equal to the same thing, divided by 2a. So that gives you one real solution. And the last possibility is that the discriminant can be less than 0, also known as negative. And that means we would have two imaginary solutions. Remember, those are the ones with i's in them. So in the past, when you've solved quadratics, if you've gotten a negative discriminant, your teacher probably said, that means it has no real solution, so we stop. Well, we don't stop anymore because this is Algebra 2 after all. We keep going and we find the imaginary solutions because we know that we can have imaginary solutions instead of real solutions. So that's how the discriminant works. And like I said, the discriminant is just a good way when you're starting these problems. It indicates what kind and how many solutions you will find. So let's do a couple examples with the quadratic formula. I think that once you see one or two of these, it might all come rushing back from Algebra 1. People like this because it's just a formula. They get to plug stuff in. And then the tricky part always with it is when you're plugging it in to actually do the arithmetic correctly. So using the calculator properly and things like that is usually where people mess up. So if we have negative 5x squared minus 2x equals 8. First thing we need to do when we're solving a quadratic equation with the quadratic formula is we need to get equals 0 on one side, so we're going to subtract 8 and we're going to get negative 5x squared minus 2x minus 8 equals 0. So the reason I'm going to use the quadratic formula on this is because of this negative 5 hanging out here in front. That just makes it really messy to try and factor or to complete the square. We could do either one of those, and if you're super interested, we'll have a lunch math party one day, and I can show you how you could still do this with completing the square or factoring. But for our purposes, using the quadratic formula is going to be the most straightforward way to do this. So I'm going to identify A, B, and C. And then I'm going to plug those into the quadratic formula. So x equals the opposite of b, so the opposite of negative 2 plus or minus the square root of b squared minus 4 times a times c. All of that over 2 times a. Now we got to just start doing that math. Negative and negative make that a positive 2, plus or minus the square root of negative 2 times negative 2 is positive 4, minus 4 times negative 5 is negative 20, and negative 20 times negative 8 is positive 160. So I put that there, all over negative 10, because 2 times negative 5 is negative 10. I can see right here that this is going to end up being a negative number, so I'm going to get x equals 2 plus or minus the square root of 4 minus 160 is negative 156 over negative 10. And because that's a negative 156, my discriminant is less than 0, which means I'm looking for two imaginary solutions. Okay, so just something to keep in mind as we're going through, we're going to have i's in our answer to this problem. So I'm going to say 2 plus or minus, now I can't do the square root of negative 156 on the calculator, but I can do the square root of 156, and I get 12.49. And then because this was negative inside the square root, I put the I after that. And it all gets divided by negative 10. Now at this point with this problem, there's not a whole lot more we can do because this is real and this is imaginary. This is also real, so I could split this up a little bit more. And this negative 10 is actually 2 times negative 5. So I can take out a 2 from both of those. So this one's 2 times 1. And 12.49 divided by 2, so that's 2 times 6.245i. So when I look at all that with the 2's, and I know, let me zoom in for a minute for you. I know, do you like my sound effects? Wonderful, right? There, now you can see all those 2's. So really what this simplifies down to, all of those 2's cancel because there's 1 in each part. And we get x equals 1 plus or minus 6.245i all over negative 5. Not the prettiest answer in the world, but the correct answer. This is two imaginary numbers because one's the plus and one's the minus. So we're good. So let's go on and do a second example. Again, using the quadratic formula. Just practicing with those numbers, putting them in the calculator and all that is really, people are like, I don't have to do this, I already know it. But I promise you, when you start actually typing it in the calculator, all bets are off. And that's where people make all kinds of mistakes. And they're like, but is it a negative negative or is it a positive negative? The more you practice, the better at that you'll get. So really doing practice is the best thing for right now. So 7x squared plus 2x plus 3 equals 8. So again, I want to start by getting equals 0, so I'll subtract 8 on both sides, which will give me 7x squared plus 2x. 3 minus 8 is minus 5 equals 0. Again, I go through and I identify my A, B, and C. So A is 7, B is 2, C is -5. So x equals the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So x equals, well, the opposite of 2 is -2 plus or minus the square root. 2 squared is 4. What is that? 4 times -5 is -20 times 7. I just did that because I thought maybe I could do it in my head then. Whoops. 140. So that's 4 minus -140. Minus -140 again, in case you need that. And then 2 times 7 is 14 on the bottom. So x equals -2 plus or minus the square root of 4 minus -140. Well, minus -140 really means we would add it. But if you type it in your calculator just like that, you'll get positive 144 over 14. Again, at this point, we want to just stop and think. Here, our discriminant is greater than 0. Discriminant greater than 0. So we're going to have two real solutions we're going to look for. So we can carry on. X equals -2 plus or minus square root of 144 is 12. Oh, I knew that. Silly. I picked up my calculator for no reason. So now we can split it up into the 2 plus and the 2 minus. So x equals 2 plus 12 over 14, or x equals 2 minus 12 over 14. Well, 2 plus 12 is 14. Sorry, that was a -2. That's a -2. I caught my own mistake. -2, -2, -2, -2. Whew, that was a close one. -2 plus 12 is 10 over 14. And -2 minus 12 is -14 over 14. But -14 over 14 is -1. So my two real solutions are 10 over 14 and -1. Again, we're just going through the motions, plugging in, finding A, B, and C, plugging them into the formula, chugging through the arithmetic. My suggestion actually for example 3, I'm going to make it a forced suggestion. Example 3, I'm going to write down. I'm going to have you pause the video and take a few minutes to try to solve it yourself, and then come back and see the solution. So example 3 is 2x squared plus 4x minus 2 equals -4. So stop the video now, and then you can come back and find the solution in a few minutes. I'm going to work through it. I'm not going to talk. That also will give you a chance just to see as you go through it if you did the same steps in the same order. Starting it now. So if you haven't done it yet, stop and do it. Zero. One solution. Okay. -4 plus or minus 0 is still going to be 0. My one solution is -1. Thank you very much for your time and attention. Have a wonderful day.